Hello, this is Jack Armitage presenting our paper, Design Process in Visual Programming, Methods for Visual and Temporal Analysis, by myself and my co-authors Thor Magnusson and Andrew McPherson. Visual programming languages such as Pure Data and Max MSP have been prevalent in computer music for nearly 3 decades, yet few shared and consistent research methods have emerged for studying their usage reproducibly. In this paper, we introduce straightforward methods for extracting design process data from PD usage through automated version control and protocol-based annotation. 4 groups of digital musical instrument designers participated in a 1-hour activity where the goal was to explore an instrument and develop its character. The brief was simply to continue finishing the DMI in any manner the group deemed appropriate. The point was not to see if participants could complete this brief within 1 hour, but to see how they would approach the task and what they would do with the time available. The groups worked with a kit called the Unfinished Instrument, which was a laser-cut wooden structure that held 4 capsule microphones, which were themselves connected to 4 Kepler-strong string synthesis algorithms in Pure Data. The instrument ran in real time on a Bella device, and the groups had shared access to Pure Data as well as the Bella debugging tools, including a browser-based oscilloscope. The Pure Data patch itself consisted of 4 identical blocks which processed the microphone input through a delay line to synthesize a plucked string sound, plus some debugging tools for convenience. Abstracting the patch visually creates an overview which we can use to compare the resulting patches against. To analyze the final state of the PD patches visually, we created a simple annotation schema whereby objects were replaced with colored squares based on whether they retained their original position or were moved, whether existing objects were edited, and whether new objects were added. Comparing across the 4 groups reveals certain patterns. We can see that 3 out of 4 groups all edited the same objects in red, which turned out to be related to the microphone signal processing. Groups 1 and 4 made significant additions to the patch, whereas Group 3 did not. We can also zoom into an individual group's edits to see in more detail what was happening. Here, for example, we can see how Group 1 separated out one of the string synthesis blocks so that they could add their own control structure inside of it and debug its behavior. Temporally, the size and frequency of automated version control changes can be used as a proxy for design changes, and again the 4 groups show different patterns of activity. Longer gaps between commits indicate that patch development and group discussion was taking place. In the paper, we cross-validate the visual and temporal design data against post-activity interview quotes from each group. We then go on to discuss how these methods could be enhanced and further developed, addressing validity, scalability, replicability, and generalisability. I look forward to your questions and comments about this paper. Thanks for your attention.